What if you could stop a motor failure from the other side of the world before it turns into a factory disaster? Today, we are upgrading our ESP32 PLC with a remote shutdown relay and transforming raw electrical signals into a high-end IIoT dashboard. We are moving beyond monitoring and into full-scale industrial control. Let's dive in. In the last episode, we hooked up the ESP32 PLC to the PZEM-004T to monitor energy fluctuation and sent the data to the Raspberry Pi Node-RED Edge gateway. We will first upgrade the circuit from the last episode to include a relay connected to pin D4 of the ESP32 PLC and to the VCC and GND. The relay NO and COM outputs are connected along the live supply to the load for remote shutdown. In FLProg, add a digital output tag for the relay. Assign it to pin D4 and drag it into a new board above. We will now create a Modbus coil with address 0 and connect it to the relay. Then compile and upload to the ESP32 PLC. In Node-RED, let's first process the Modbus read data of the PZEM-004T energy monitor from the previous video. Connect a function node to the ESP32 Modbus read node. Double-click on it and go to the Setup tab to increase its output to 6, corresponding to the number of PZEM parameters. Copy this code from the GitHub link in the description and paste it here for the data processing. The code has functions to process the raw Modbus energy parameters and output them as the actual 2 decimal place values of voltage, current, power, energy, frequency, and power factor. Notice that the function node now has 6 outputs, which we can connect to the debug node. When this Node-RED flow is deployed, the processed energy outputs of the function can be seen as debug messages. To see these messages, I manually energized the relay to turn on the load since I am yet to create the required flow. We can install and configure a dashboard in Node-RED to display the PZEM energy parameters. Go to the Manage Palette menu option. Search for the FlowFuse dashboard in the Install tab and install it. Scroll down the Nodes palette to see the different dashboard nodes. Let's now drag in 6 of the gauge nodes and connect them to the output of the function. Double-click on the first gauge node. Select the available group and change the name to gauges. Adjust the size of the gauge to 6 by 3. Select your required type and style. Ensure that you remove S from payloads in the value field if present. Change the range maximum to 450. You may adjust the segment value to suit your purpose, but I will delete all but the first. Under Labeling, change the label to voltage, the unit to volts, and click on Done. I will do the same with the next node for the current parameter, with the maximum range of 0.1. The current label and ampere unit. The same goes for the power, with a maximum range of 10, and the unit of watts. And for the energy, with a maximum range of 10, and a unit of kilowatts hour. The frequency maximum could be 70 Hz. And finally, the power factor with a maximum range of 1. Now, rearrange the order of the parameters in the Dashboard Layout tab. Note that the range could be adjusted depending on the load and power specifications. To show the trends of each parameters, let's drag in and connect the chart nodes to each gauge node. Double-click on the first chart node. Name it Voltage. Add a new group. Name it Trends. And select page 1. Adjust the size to 6:3. Set the x-axis limit to 1 minute. The y-axis label to voltage with V in brackets. And change the property series to none. Move on to the next chart node for the current and place it on the same trends group with a similar size of 6:3. The x-axis limit should also be 1 minute. The y-axis label to current with A in brackets and the property series to none. Repeat the same steps with the appropriate units in the same trends group for the power, energy, frequency, and power factor. Rearrange the order of the parameters in the Dashboard Layout tab if required and deploy the flow. Open the dashboard from here and observe the energy parameters on the gauges and the trends. Let's go back to the Node-RED flow and add 2 dashboard switches. Also add 2 Modbus write nodes and connect them to the switches. Double-click on the first switch and add a new group for the switches. Select the existing dashboard page and adjust the size to 12:1. Label the switch Relay and select an appropriate layout. Also configure the other switch with a label of Reset. Now configure the first Modbus write node as a Modbus function of FC5 with an address of 0 and select the existing ESP32 PLC server. Similarly, configure the second node with the address of 1. Deploy the flow and go to the dashboard. The switches are now available to turn on and off the load and reset the energy counter. We've moved from raw data to a professional dashboard. If you found this useful, hitting that like button helps me reach more makers and engineers. We are just getting started. In the next episode, we are moving this dashboard to your smartphone with live mobile alerts. Subscribe and join the journey because the future of industry is connected. I will see you in the comments.